Hey class, Mrs. Anderson here with my assistant. What's your name?
Mia, and I'm making a funny face.
She's making a funny face. I wanted to pop in and say hi. I hope everyone is doing well. I have had a couple questions, so I just wanted to address those, and my assistant here wanted to help. So, first question was, only the odd answers are posted on solution keys. Do I still have to do the whole assignment? The answer is yes. I still want you to do the whole assignment. I only posted the odd solutions to try to discourage so much cheating. Mia, come on now. I wanted you to still be able to check your answers, but not necessarily be able to just copy the whole answer key. Since the completion folders, the rules don't really work. You can usually open the answer key before you make a submission. So that's why I did that. Second, I'd really love to see more of you guys during office hours or, asking me for help. I'm available throughout the week. I'm pretty flexible, so I'm just home, working, taking care of this one. Just let me know. If you can't make office hours but you have questions, I'm flexible to meet during other times. The third thing that has been a question for lots of students is the problems on the bottom, the graphing problems on 10.1c. So I just wanted to... All right, third, the other question I'm getting is questions on the bottom, questions on 10.1c, where it is the graphing problems. And so I just wanted to remind you that you've seen something like this before when we graphed exponential growth and decay. It wasn't in the initial video because geometric sequences are very similar to exponential growth and decay, and we graphed those before. So if I gave you something like this, really you could think of that as an exponential growth function. It's very similar to that, where then your x minus h plus k. So if I ask you what the shift is, and the shift is at positive 1, 0, and that comes from this 1 up here, and then there's nothing being added at the end. And then when you make your table, just like we did with exponential growth and decay, you pick negative 2, negative 1, 0, 1, and 2. And then your b to the x, or this one would be 3 to the n, and you would plug those in, so you'd have 3 to the negative 2 power. Remember, that's 1 over 3 squared, so 1/9. 3 to the negative 1 is 1/3. 3 to the 0, 3 to the first, 3 squared. And then your a value out front would be times 2 in the third column. So 2/9, 2/3, 2, 6, 18 for this particular example. And then when you're graphing it, you would graph from your shift 1, 0, and this is exponential growth, so it would look something similar to this. Now I just sketched a quick sketch. Then remember, exponential growth functions have a domain of all real numbers and a range depends on your shifted value. You can see from my picture, all of my y values are above 0. So my range is greater than or equal to 0. And then remember that asymptote line is at y equals 0. So hopefully that helps you with graphing those bottom examples on the worksheet 10.1c. That gives you a little bit of an idea for that. All right, thank you.
Hi, thank you for watching the video.
Say have a nice day.
Have a nice day.
Let me know if you have questions. I'm here to help, okay?
Here to help.
Here to help.